We're at the end here. We're going to do a couple inverse problems for review for our final, and the question is, which of these is the inverse? Now, some of you will try and look and just say, oh, I can just switch it. Well, that's a harder thing to do than you might think. What I would suggest is switch x and y first. That's a fancy y, right? Y equals mx plus b, basically. So change it to x equals 2 times y minus 1. Okay? And so therefore, now all we have to do to find our inverse is solve for y. We'll start out by adding 1 to both sides. So you get 2y equals x plus 1. Now we're dividing by 2, but we're dividing by 2 over the lot of it. So there's nothing that looks like x plus 1 over 2 collectively. But there are a couple here that do have an x that's over 2, since that whole line says that everything here is over 2. So you can call it an x over 2 plus a 1 over 2. That's the way it would be. That's the answer D. Same thing here. Which of the following represents the inverse of this? Well, do the same thing again. You got x equals 1/2 of y plus 2. We start by subtracting the 2. So you get 1/2 y is equal to x minus 2. Now to get rid of that, I wouldn't try and divide by a fraction 1/2. I would in turn multiply by 2, because that's going to do the same damage. Go over here, you multiply by 2, it looks like a square. You're multiplying by 2 in limited space. Distribute that 2, you end up with a 2x minus 4. That answer is, oh, who just lied to you? Well, I'm going to make up a question E. E is f inverse of x equals 2x minus 4. And we'll say the answer is E.